Assalamu alaikum wa rahmatullah. For this session also, we continue with the blood and with the blood cord cell. Yesterday we discussed the type of blood cells and blood tissues. So yesterday we show you one of the slide and the component of the blood, and we told you that it consists of the plasma, which is up here, and the buff of white blood cells. It is. I know that you will not be able to see it. I will pass that tube to you in order to see it properly. And a buff of white blood cells. It is between the plasma and the red blood cells and those other cells and the platelets. So, but don't move it, because if you move it, it will be mixed. So you will not be able to see anything after that. It will be a whole blood. So just hold it like this and you can see the difference between the plasma and the blood cells and the white blood cells. Two tubes are there. One of them, I think it is slightly moved. Because of that, you will see some redness above in the plasma. It means that some red blood cells are there in that tube in the plasma side. So just pass it without moving it. See it and pass it. Don't move it. Don't shake it. لا تحركه بس. This one, the other one, it is another type of tube that separate the serum. It is the serum and the blood cells. So this one, if we shake it, if we do anything with it, it will not move, because there is some substance which is there, a gel is there, which separate the cells between the cells and the serum. It is the serum because the blood is clotted here. You will understand that later. So you can see this one. This is different. The component of the serum, it is different than the component of the plasma itself. You can pass also those one. Those one, if you shake it, no problem. So we will continue with the forms white blood cells and platelets. So the formation, as we said, of white blood cells, yesterday we discussed how it is formed. The formation of leukocyte and the platelets is similarly by hormonal action. So colony stimulating factor and interleukin or leukocyte, which help in the formation of white blood cells. The hormone also thrombin, it will stimulate the production of the platelets. So those are the hormones that will help in the production of the blood cells. So the hemocytoblasts or stem cells, lymphoid stem cells, and myeloid stem cells, as we mentioned yesterday, it will produce secondary. This is also called the secondary stem cells. Stem cells, which is the mother cell that produce the. Which one? Just this is the serum, the up, and the in between it is gel that separate the serum from the clotted blood. So then this lymphoid stem cell, it will produce lymphocyte, and the myeloid stem cell, it will produce the basophil, eosinophil, neutrophil, and monocyte, and the platelets and erythrocyte. So this is again That's one of the slides that we will mention yesterday. Now we will come to cover another objective, which is describe the process of hemostasis and the importance of blood clotting. When in a normal life, usually, and we said that the blood, it is a fluid that's run inside the blood vessels. It has to be run smoothly. There should be no clotting. There should be, this is normal life, it should run smoothly in order to transfer nutrient material, in order to transfer oxygen, in order to transfer also waste product to all body tissues. Now, if any injury happened, if any wound is there, just show it. Did all of them see it? Okay, just put it here. Thank you. So, if any injury happened to the blood vessels, so there should be some protective measures, some physiological measures that prevent the loss of blood from our body. If the blood is lost, it means that no transmission of nutrient, no oxygen will reach the our body cells. So how metabolism happen, how the cells can do its action. So there should be some measures that physiologically start when there is an injury in order for the continuation of the life of the cell and continuation of the life of the human body or the creature, because all human body and animals, all of them, they are having blood, and that blood has the same function in their body. So hemostasis, it should be there in order to prevent the blood loss. What will happen in case of injury? There are three categories of. So first, we will see what's the meaning of hemostasis. The hemostasis, it is the natural process that stops the blood loss when any injury occurs. The injury, it can be injury to outside, like wound, that open wound, and we can see the blood when it is coming out. It might be internal injury, internal bleeding, it can be there, or it can be injury to the wall, small injury to the wall of the blood vessels. Sorry, it might be the lining of the blood vessels. So in cardiovascular system, we will discuss that more. So this process, it helps in the stoppage of the blood loss and prevent blood loss. So it involves three main steps. The first one, it is vasoconstriction. So in order to decrease the amount of blood flow, what will happen? There will be constriction of blood vessels. When the blood vessel is constricted, what do you think? The amount of blood which will go inside that blood vessels, it will be low or more? So it will be less because it is constricted. So the pathway is narrow. So the amount of blood loss, it will be less in this case. So vasoconstriction, which is brief contraction of blood vessels. The second thing, which is formation of platelet plate, that will cover that opening. So the help of vasoconstriction, when vasoconstriction is there, the injured site also, it will be less, and that platelet plaques, it will be easily formed and coat that site, that open site of the wound. Then the third step, it will be the blood clotting or coagulation, which will strengthen the platelet plaque with a fibrin mesh. So formation of fibrin mesh will be there. That act as a glue and hold the clot together and close the site of bleeding and prevent the blood loss. So first, there will be vascular spasm, the smooth muscle contract, causing constriction of the blood vessels. So the pathway of the blood, it will be small, and the amount of blood in this case which moving in that blood vessels will be less. The second thing, a platelet plaque. So a platelet will come into that area and try to plug it, close it. Injury of lining vessels, when the lining of the blood vessels is injured, it exposes the collagen fiber. So that will lead to platelet adherence. The platelet, it will adhere to it. Then the platelets release chemical that make nearby platelets sticky, and it will form platelet plaques. The platelets that come to that injured part, it will stick to that part. When it stick there, it will release a chemical substance. That chemical substance, it will attract other platelets تجذب الصفيحات الأخرى to the area, and by that they are forming a more plaque there in order to close the area. So platelet release chemical that nearby platelets become sticky and platelet plaque will form. Then the step 3, coagulation. Fibrin it will form a mesh, like the fibrinogen, it will be forming like threads. So it's like a mesh that will close also and help in the closure of the wound. So form mesh that trap the red blood cells and the platelet from and forming a clot and prevent the blood from going out. So the event of tissue repair then will come. Did you understand what's going on?
Yes.
Yes. There are 3 steps. What is the first step? Vasoconstriction. So the first one is vasoconstriction. The second step, طبعا, why vasoconstriction will be there? Whenever injury is there, also chemical substance will be released from the tissue, that injured tissues. That chemical substances, it will lead to stimulation of vasoconstriction. And also the lining, all of it is a chemical processes. So vasoconstriction will happen. The lining of the blood vessels also, it will attract the platelets, and the platelet will adhere to the lining, forming the plaques. It will release, when it adhere also, it will release chemical substance. That chemical substance, it will attract more platelets. The third thing, the formation of platelet, also the blood clotting. So the blood will clot and form a mesh-like substance that close the area or close the opening of that blood vessels or the injured site of the blood vessels and form the clot. Now, after that, there will be a tissue repair. When injury is there, that tissue which is injured, it will be used. It has to be removed from that area, and then a new tissue will be built to replace the destructed tissues. So what will happen? Inflammatory reaction set those stage. What is the inflammatory reaction that's happened? One, injured cell release inflammatory chemical substances. That chemical substances, the capillary become very permeable. What's the meaning of permeability?
Ability to transport the.
Yes, so it will, thank you. So it will lead that the ability to transfer substances from in and out. So the destructed cells and end product of destructed cells, it will go in order to be as a waste product, and the nutrient, it will be sent out in order to be used for building material for new tissues. Capillaries become permeable. Fluid rich in clotting protein migrate into the area from the bloodstream. So that will help in the process of clotting. And clotting protein construct a clot to stop the bleeding and prevent the spread of bacteria, because when any opening is there, it is a site for portal of entry for the bacteria. So when it is closed, we are closing the portal of entry. A clot wall of the injured area forming a dry scrap material, so it will be dried out. Then the granulation tissue will be formed. The granulation tissue, this is the soft tissue that you will see it when the tissue start to heal. We call it the granulation tissue. So a delicate pink tissue called the granulation tissues grow in the damaged area. It will start to grow in the damaged area. A new cell will be formed there. And the granulation tissue is composed of new capillaries will be formed. The new capillaries, in order to give more blood supply to the area, because that injured area, it needs now more blood supply in order to repair the tissue which is damaged. Like if anything happened to the one wall of the house, what we are in need for supply. We are in need for blocks, we are in need for sand, we are in need for cement in order to rebuild. So here, that material, that building material, it has to become through the blood. So a new capillary will be formed in that site. Because of that, you will see that redness will be there due to inflammatory process and due to formation, due to attraction of more blood supply to the area. So the growth the granulation tissue also contain the phagocyte. What's the importance of phagocyte? What's the function of phagocyte?
Fight.
It fight bacteria and also dead tissue. There are many dead tissues are there. So that dead tissue, it need to be engulfed and removed from the area. So phagocyte, which is from the white blood cells, it will immigrate there and it will act on the dead tissue in order to remove them from the area. And if bacteria is there also. So the phagocyte, which gradually also dispose the blood clot. Also, the blood clot, after if it is formed, we didn't want the clotting to be continued forever. Otherwise, it will block up the blood vessels, and in this case, the blood supply to the area, it will be diminished. So then that phagocyte also, it will help in keeping the patency of blood vessels after that. Rebuilds collagen fiber, which is the scar that you will see. الندبة اللي بنشوفها بعدين. The scar that you will see, it will be rebuilt by that. Regeneration of structure of the epithelium. So the surface epithelium regeneration beneath the scab will be there. So scab, they detach fully and regenerate the structure of epithelium. The epithelium, it will be regenerated again and reformed. Cover the underlying area of fibrous scar. So it will cover the underlying scar, the scar from inside. Whether scar is visible or invisible depend on the severity of the wound. When the wound is too big, when crushing is large area, when it is irregular, you will see the scars, and the scar, it might be for the long life sometime. If the wound is small, sometimes the scar, it will be for a period of time. After that, it will disappear. You will check, there were some injury here, but now I couldn't see it. But immediately or during the few weeks or few months after the injury, it might be apparent there. So it depends upon the size, the scar, it depends upon the size of the injury which was there. Did you understand what we were talking about?
Yes.
Okay. So again, this is what's happened during the hemostasis, vascular spasm, platelet plaque formation, blood clotting and coagulation will be there, and formation of the clot. Again, the vascular spasm, it is the immediate response to blood vessels and injury. Vasoconstriction will be there. It will decrease the amount of blood to the area. So it is sudden involuntary contraction of the muscle will happen in case of injury. Spasm will narrow the blood vessel and decrease the blood loss until clotting happens. Platelet plaque formation, the collagen fiber are exposed by the broken blood vessels. Then the platelet become sticky. This is a repetition of what we said before. Cling to the fibers. Anchor the platelet release chemical serotonin, the chemical substances that released from the platelets to attract more platelet there. Platelet built up and form platelet plaques, which is the white thrombus. Then blood clotting and coagulation. The injured tissue, it will release tissue factor. That factor interact and combine with B fibrin 3 or phospholipid, B phospholipid 3. This combination of TF and BF3 interact with other blood protein clotting factor plus the calcium ion to form activator. That activator will lead to formation of thrombin through the assistance of enzyme. So thrombin joint, the thrombin, which is an enzyme, it will join the fibrinogen, which is a protein in their link fibrin, and fibrin form the meshwork. The meshwork that strap the red blood cells or the whole blood from the base of the clot. So blood usually clot within the time of clotting, it is from 3 to 6 minutes. Because of that also, in order to help the normal physiology, when there is any bleeding, we have to do compression over that. That compression, it will help in the process of preventing the blood from coming out, also help in the spasm, and help in preventing in the clotting. So we have to compress, as you learn in first aid, if you remember, for 3 to 6 minutes, and you should not release. If you are if you put gauze or dressing over it, you have to wrap it with the bandage without removing it again, because when you are removing it, you are removing the clot. So the clot remain as the endothelium cell layer lining the inner surface of blood vessels. It will be regenerated. So the clot is broken down after tissue repair. It will be broken down. So it will lead to formation of those like a thread, which is, we call it the mesh. So this is the fiber, which form fibrous tissues. The other objective, which is describe the type of blood, which is the ABO types. Sorry. Describe the ABO and RH blood grouping, and explain the basis for transfusion and reaction. You know that every one of us may have a different type of blood, having, which we call it the blood group. What's your blood group? You don't know. Say it.
O plus.
O positive.
Same.
The same blood. A positive. So anybody is having a negative blood group? All of you positive? ليش ما تعرف؟ عمركم إياه قبل. Okay, no. So what is the difference between? What is the difference? What's the O? What's the B? What is the what we mean by that?
Antigen.
It is antigen. So it is related to certain antigen. So there are antigen in our body. There are antigen and antibodies. So that antigen, it is on the surface of the cell, and the antibody is where? The blood component is composed from the cells and the plasma. So the antibodies is present where? In the plasma. So in order to, and so there are two type of antigen, either antigen A or antigen B. or no antigen. When there is no antigen on the cell,
Oh.
it is O. If antigen is there, either one antigen will be there, either A or B, so it is A or B. When both antigen are there,
Maybe.
it is AB. In the plasma, the antibody, it will be
Different.
different. So if A,
B.
the antibody will be
B.
for B. If B,
A.
the antibody, it will be A. If O,
AB.
the antibody will be A and B. So, so this is will form the different type of blood group. Then we will come to the positive and negative, which is the rhesus factor. So some people, they are having negative rhesus factor, and some of them, they are having positive factors. So the importance of understanding those types of blood in order to understand if that person is in need for blood transfusion, in order to give him the specific group that it can be transferred to him without making any reaction. You will understand it after we start with that. So the blood group, blood and blood transfusion, طبعا large loss of blood, if large loss of blood is happened due to injury, in this case it is maybe serious condition and it might lead to death. Because of that, we need to have blood transfusion. So a loss of 15 to 30%, it will cause weakness. If more than 30%, it will cause shock and it can be fatal. So it depends upon the type of loss and that loss, if it is a sudden loss or if it is gradual. When it is gradual, the normal physiology of the blood of the body, it can act and it might help in the process and of the person to deal with that. And it will help us also, give us a time in order to deal with this condition in a specific way. But if it is sudden, in this case, sometimes you will see the announcement that we are in need for which group? When in case of emergency, which blood group is needed mostly? Or which type of?
Minus.
O positive. O negative, sorry. So O negative is needed in case of emergency because the O, it is called universal donor, that can be given to all blood group because it doesn't have an antibody inside the plasma, so no reaction will happen. So transfusion are the only way to replace the blood quickly. Blood transfusion is given for substantial blood loss, to treat severe anemia, for in case of anemia. Also transfusion of blood must be the same blood group that the person is having. So as we said, if donor is O, he can give to, if O negative, he can give to all type of blood. He can give to O, to A, to B, and to AB. If it is negative, he can give to all blind. If it is positive, he can give to all positive only, but he cannot give to negative. A can give to A and AB. B can give to B and A, B. But AB can give only to AB. It cannot be given to any other type of blood group. Because of that, it is called universal donor. Universal donor. معطي عام. AB, universal recipient. Universal recipient يعني he can receive from anybody. مستقبل عام. He can receive from all type of blood group, but he cannot give. And only he can give to A, B. So he can receive from all, but he can give only to A, B. فهذا كريم وهذا بخيل. مش الشخص البخيل طبعا. So human blood group, there is, as we said, there is antigen, which is antigen. It is any substance. Example: bacteria or virus that when it is enter the body, it is defined, identified as a foreign body, and cause the immune system to produce antibody. So antigen, it is any substance that when entered the body, it will be identified by the body tissues as a foreign body. And the body will react against it and form antibodies. The antibodies, specialized substance. So it is a specialized substance produced by the immune system to neutralize a specific antigen. So it is a specialized substance formed against specific antigen. If you are having antibodies against a certain bacteria, it will not act on another bacteria. Because of that, we are getting different type of vaccination. One vaccination, it cannot be used for all kinds of disease. The plasma membrane of the red blood cells contain the genetically determined protein, which is the antigen, or the agglutinators. So the antigen is present here in the surface of the red blood cells. The antigen A or the antigen B. But since they are our own, it is isoantigen. So our body will not act against them. My blood group is B positive. So I am having B antigen and I am having the rhesus factor positive. So my immune system will not act against them. Why? Because they are from my own tissues. You are having a blood group. You are having that A antigen. If I receive that A antigen, my body will react against it. If I receive your A antigen in my body, also it will be identified as foreign body. So my immune system, it will react against it. And it will lead to agglutination. But so, as we said, it is isoantigen or self-antigen, so the body will not react against those substances. One person, red blood cells antigen will recognized as a foreign if transfusion into another person who has a different red blood cells antigen. So reaction can happen if we transfer a blood group, a different blood group, to a patient who is having different from patient who are having different blood group. Because of that, we have to be sure that the blood group is a specific blood group that we give to the client. And when you will go to the hospital, you will find that before that transfusion, even if they know the type of blood of that client, of that patient, they will take another specimen. They call it for cross-matching. Cross-matching, it means that they have to match the blood, even if it is from the same group, with the unit of the blood which is there in the lab, in the blood bank. Because there are also some, what we call it, the subgroup. So there might be some other sub-antigen is there, which might lead to reaction. In order to prevent that reaction, we have to do the matching test, cross-matching test. Because of that, never give blood without sending a specimen to the blood bank for cross-matching. So the ABO group, the red blood cells, the A, it is containing the antigen A, the B is containing the antigen B, the AB containing antigen A and B, the O is containing 0 antigen, so there is no antigen in that. So the antibodies in the plasma, here the cell, the plasma for blood A, group A, it has antibody B. The group B, it has the antibody A. The AB, it doesn't have antibody in the plasma. Because of that, it can receive any type of blood. It will not react. The O, because there is no antigen, so the two antibodies, antibody A and B, are there in the O, in the plasma. So it cannot receive any other type. So the antigen in the red blood cells as antigen A, here antigen B, here in the AB antigen A and B, and O there is no antigen. Did you understand what's the difference? And why we can give this type of blood or we cannot? So A cannot be given to O, B cannot be given to O, AB cannot be given to O. Only O can receive from O group because there is no antigen. If it is given to O, the antibody is there for A, if we are giving A. So the antibody is there in their plasma. Immediately it will act, it will attack the blood cells that we give, and it will lead to agglutination. And it will lead to reaction, the blood reaction. So the patient will have a reaction in this case. So the effect of incompatible blood transfusion involve recipient plasma antibodies and the donor red blood cells antigen. So group A recipient has antibody B, as we said, in the plasma. So the donor group B RBCs, when it is given, it will be agglutinated. So the result, recipient antibody attacked the donor B antibodies RBC and club together, agglutination will happen, lead to rupture of red blood cells and hemolysis of blood cells. So the blood cells, it is not only useless, it is harmful in this case. So we are giving him blood, but in order, instead of helping him, we are aggravating his condition. If we are giving a different blood, that is not suitable for that client, instead of helping him, we are aggravating his condition. Why? Because his antigen, the antigen in his body, it will attack the blood cells that we gave to him, and it will lead to rupture of those blood cells, and it will lead to hemolysis, and in this case, a long process will happen, and that a long reaction will happen to that client. That it might be fatal if he got a large amount of blood. Because of that, even though after all the examination, after all the investigation that we did the blood group for the client, and we did the cross-matching, when we start transfusion, even if when we are checking that it is the same blood group and it is the same unit that we did the cross-matching for it, we have to start also giving blood very slowly in order to detect any reaction immediately when it is happening, if reaction is happening. We will stop now and we will continue after the break. Thank you.